Chapter 5, Friction, Samples. Sample. A block of mass 3.5 kilogram is pushed along a horizontal floor by force P equal to 15 Newton at an angle 40 degrees to the horizontal, as shown in the figure. The coefficient of the kinetic energy between the block and the floor is 0.25. Calculate A, the frictional force exerted on the block, this one. B, the acceleration of the block. Now, let's try to get the free body diagram. This block moves towards the positive direction of X along the horizontal. How many forces acting on it? Normal force, gravitational force, frictional force, and push P. And let's write it X in Y direction. N minus P sine 40, this one is minus. Minus mg equal to 0 because vertically it does not move at all, no acceleration. Horizontally, you see, P cosine 40 degree minus F equal to ma. We don't know F. F is what? F is mu n. N here is P sine 40 plus mg. And we put this one, we get F. F is 11 Newton. We put F in, 4 in, then you can get A. A is 0.14 meter per second per second. Sample. A block A of mass M1 is connected to an object B of mass M2. Throw a light core as shown in the figure. The inclined plane is at angle theta to the horizontal. The coefficient of friction between the block A and the inclined plane is mu. Find the acceleration A and B. B, tension T in the core. Neglect the masses of the core, pulley C and D, and the frictions between them. Now, let's write the free body diagram for block A and block B. Block A. How many forces acting on it? Gravitational force M1G. Pulling force T from the rope. Normal force from the inclined surface. And the friction opposite the direction of moving. Let me write, we take the reference X along the inclined surface up, and the block 1 has acceleration A1 along the surface. Now we write the equation. Along X, T minus M1G sine theta minus friction F equal to M1A1. Vertically, N minus M1G cosine theta equal to 1, because along this direction, no motion at all, no acceleration. Look at block B. When A going up, B going down. So this is a T, this is a T. So this is a 2T, this is a 2T. M2, G minus 2T equal to M2A2. Now here you have to notice A2, A1 are different. You see, when A going up 1 meter, and this up have to split into 2. So the B going down only ½ meter. So in this case, we have a relationship between A1 and A2 is A1 is 2A2. And also the friction is mu and 1. These 5 equations, we can solve the 5 unknown. T, F1, A1, A2, N. This is the answer. I'm not going to do it because it's very simple and tedious algebraic calculation. Sample. As shown in the figure, the coefficient of static friction between the rope and the cylinder surface is mu. And the angle which corresponds the contact arc between them is θ0. Calculate the ratio tension TB over TA on the 2 ends of the rope when the rope is on the verge of sliding. We write a diagram like this one, okay? This is angle, of course, 2 pi, 4 pi, 3 pi. We call it θ0. This is a TB. TB end is heavy end, okay? This is TA in your hand is light one. So the rope have a tendency slide this direction, and the friction is opposite the direction, go direction, okay? Goes this direction. The question is very hard because the tension in the rope changes all the time. Because this is smaller, it's larger, and the larger, or smaller, okay? So what we do, we have calculus. We take a small section, d theta, okay? D theta, very small, and located at θ0. We take this one as a reference. This is theta, count this way, okay? Location at theta, this one. And the theta equals 0 at this section. Theta equal to θ0 at this section. Theta is between 0 to θ0 in this section as well. This is one of the section, okay? The angle is d theta, okay? We analyze this rope, dS, the situation, okay? We know this section, the red one, has tension at this end, T plus dt. At this end is T. They're different. They're different. And also we have a normal force and a friction. Normal force is perpendicular to section along the radius. And the friction, as we know, is opposite the tendency. It goes this direction. Okay. Under these 4 forces, the section of rope ds is in equilibrium at rest. Okay? Let me analyze it. F is equal to mu n. This is a rho, okay? And then we'll see, analyze the section. We take this as x direction and this as y direction, okay? We see this tension, okay, horizontally. T plus dt cosine this angle. This angle is a half d theta. We connect this one, half d theta. So T plus dt cosine half d theta, this one, T cosine half d theta is different. This is T plus dt, this is T, okay? And minus F. F equal to mu n equal to 0. This horizontal direction. And vertical direction we will see is n minus T plus ds sine half d theta minus T sine d theta equal to 0. Okay, we have these 3 equations, okay, and then we put F here, we get a 2. One is red, one is blue, okay. Now let me simplify it, because d theta is very small. When half d theta, very small, approaches 0, we have approximation. Cosine half d theta approach to 1. Sine half d theta approach half d theta. So we put this one in these two equations. This one is t plus dt 1 minus t 1 minus mu n equal to 0. This blue one is n minus t plus dt half theta minus t half d theta equal to 0. Okay, now we look at this t2. Okay, look at this t and minus t is cancelled out. This becomes dt minus mu n equal to 0. And this one, you see, you have t half theta minus t half theta. This is minus. You have minus t d theta. This is d theta over 2. Okay, equal to 0. All right. Now let's look at these two, the blue one and red one. Okay. In this blue one, I've dropped the half dt. Which compared to t is much smaller. This dt is very small because theta approaches 0. T is pretty large one, so we drop it. For example, you have 10,000 at $1. The people ask you, how much money you have? You say I have 10,000. You just forget the $1. It's just too small. Okay, that's fine. Now it becomes n minus t d theta equals 0. Okay, in this case, n is t d theta. We look at this, the red one. T and t cancel out because dt minus mu n. Okay, equal to 0. Can you drop dt like that one? No. This one, because you have 10,000 plus 1. If you have only 1, you could drop it. It becomes n equal to 0. Definitely wrong, right? So you cannot. This is the big one. Even if one is a bigger one. So you put n d theta inside. We get a dt minus equal to mu n. The n is t d theta. And move t over there, you get dt over t equal to mu. This is a different equation we got. Okay? Now, the small section, I get this equation. Okay. Actually, we can have a lot of section, different section. This is a section located at theta. Okay. Now, I label it as number I. This is number I. I can be 1, 2, 3, 4, so many, infinite. What we do, we write this equation like this one. Each section will have this equation. Then we put them together, sigma. Okay? And when we put sigma and we let d theta or dt approach the limit. Can you? Yes. Well, this one, this is a definition, integration mu d theta. D theta approach 0 limit. This is dt over t integration because dt equals to 0 limit. Okay. So this one, we rewrite this one, this become integration mu dsc. Integration td over t. From where to where? Now, when theta equals to 0, t is tension Ta. When theta equals to theta 0, t is a Tb. That's the equation. All right? So what we do, we directly write the equation. We do the integration on both sides, we get this one. And this one we see, this is log Tb over Ta equal to mu theta. And we should say Tb over dV equal to e to the mu theta. In our case, suppose mu is 0.30. Ta is 303 Newton. Tb is much larger, 9.9 thousandths Newton. And you can find the theta 0 about 3 times 2 pi. 3 wrong. Okay. Well, this is a very hard problem. You can do it. You can do it. I explained it very in detail, very slowly. As shown in the figure, F equal to 30 Newton, M1 3.0 kilogram, M2 2.0 kilogram. The coefficient of kinetic friction between the horizontal plane and the two bodies, mu equal to 0.20. Find the acceleration A2 of body M2. Neglect the masses of the pulley and the rope. Rewrite the equation for M1. F minus T1 minus friction F1 equal to M1 A1. T2 minus F2 equals M2 A2. Here we have to do this A and not the same because we have this tape. Okay. And you see how many forces? Unknown T1, T2, F1, F2, A1 is 6 unknowns. We have only 2 equations. We need extra 4. So the F1 equal to mu M1G as before. F2 equal to mu M2G. We need another equation. We look at this one. Look at the T1, T2. T1 equal to 2T2. And also, let's see the acceleration M2 and M1. You look at this one. When you go 1 meter, M1 only go half meter because this length divided into 2. So we get a conclusion is A2 is 2A1. The reason is S2 is 2S1. And they all go acceleration constant. You get 8 have the same ratio. Okay, this for 6 equations, 6 unknown, we can find A2. I don't do it. And A2 is 2.96 meters per second Sample. A block A of mass MA on a horizontal table in an elevator is connected to a block B of mass MB over a small pulley through a light cord. Block B is held in vertical position as shown in the figure. The coefficient of kinetic friction between the block A and the table surface is mu. Find the acceleration of block B when the elevator is moving downward with acceleration h0. Now let's talk about the problem. This problem seems very similar to the sample we mentioned in previous lecture, except the friction. But actually, if you carefully observe it, it's quite different. What the difference? The difference is this table, block A and B, is in an elevator. And the elevator is moving downward with acceleration h0. So, if you take a reference as an elevator, this reference frame is not inertial frame, because inertial frame, where you can apply the Newton's law, should not have acceleration. That's the issue of this question. So what we do, we're standing back to describe the motion. Standing back on the ground, you can describe the motion with Newton's law. But the difference is you stand in the elevator, you don't see block A has vertical acceleration. But if you stand back on the ground, you see that block A will have an acceleration downward together with the elevator. Now let's do it. Block A suffer friction, which is opposite its movement, and the tension from the rope. We take the reference X towards positive towards right, Y towards down. we write F at T minus F equal to ma. This A is acceleration on horizontal direction. And look at friction. The friction equal to mu n, the normal force. So friction equal to mu n. Vertically, look at the block A. It has gravitational force mag and n, only two. Does it move? Yes. You send out on the ground, you see the A move downward together with the elevator. So we see this one, mag minus n equal to ma a0. And that's the key point. Next, we just try the B. The B are the same. B accelerate except in the elevator with A downward, but also accelerate A0 together with elevator. So we look the B is mbg gravitational force minus T equal to mb to acceleration together with elevator together with A. That's the key point. Now next, we have 1, 2, 3, 4 unknown. We have 1, 2, 3, 4 equations. So principally, we can solve the question. This is a junior high school, tedious, but not difficult. We look at, you have minus T, you have T, you put this equation together, you cancel the T, but you have F. In order to find F, you have to find N. You can find N in this equation, okay? So we put together, we can find mbg minus mu ma, g minus a0 equal ma plus nb, a plus mb a0. And then from this equation, we found A. Remember, the acceleration of B is 2. A and A0. This is the A from this equation. It's A0. That's it.